Alright, hello everyone. So today we're working on a pre-calc problem, or sometimes it's in a discrete math class. So, and this is going to be a two-part series video. Part one, in part two, we're going to deal with doing the same thing in terms of expanding a binomial. The first video, which is today's video, is going to be using Pascal's triangle, and the next video is going to be by using the binomial theorem. Okay, so our problem here is to expand the quantity 5x plus 2y to the third power using Pascal's triangle. So let's start by looking at Pascal's triangle. So Pascal's triangle is that image you see, which is, or yeah, lack of a better word here, is a triangle. And it starts with a 1 on the very top, and then we give some space, and then we go down, a row or two, and then we put 1s at the end. And basically there's like 1s all over here. And some people call this, instead of a triangle, like a tree. Yeah, you always have a 1 at the end. You're going to have some stuff in the middle though. Okay, now starting from this third row of 1s, which is, let me point that out, is this one, you're going to have some numbers in the middle. And the way you get those numbers in the middle is by adding the two entries above together, and that's where the middle goes there. So that's where that space is filled in. So you have 1 here, and the 1 from the row above it. When you add those together, you're going to get 2. Okay. Then we're going to move to the next row, and I'm going to do the same thing now. I'm going to take 1 and 2, and I'm going to add them together. 1 plus 2 is 3. That goes in the middle. And then I'm going to do the same thing with the 2 and the 1. 2 and 1 is 3 as well. And let me go with one more row so we can practice this. 1 and 3. That 1 and that 3 we're going to add. It's going to be 4. 3 and 3 added is 6. And then finally, 3 plus 1 is 4. So that 3 and that 1 is 4. If you went and did this one more time, I'm just going to write the numbers out. You can check. This would be 1, 5, 10, 10, 5, 1. Okay, and this goes on and on and on. You can go as many times as you want here. Now, what's so special about these numbers? So what these numbers represent are the coefficients of a binomial that's raised to a specific positive integer. So this number 1 here stands for a plus b raised to the 0. The second row is a plus b to the first. The third row is a plus b squared. The third row is a plus b to the third. The fourth row is a plus b to the fourth. And then finally a plus b to the fifth. Okay. So the rows, the numbers themselves represent the coefficients of the terms that you're going to have. So let me show you how this works with a plus b to the third, because we're interested in expanding the third power. And a and b are just two expressions here. I'm going to have variables or whatnot. And here's how this works. I'm going to grab the numbers that you see, 1, 3, 3, 1, that are associated with a plus b to the third. And here's how this works. You're going to take 1 times a to the third plus 3 times a squared b, and I'll explain that in a second, plus 3ab squared plus 1 times b cubed. So each of these numbers, 1, 3, 3, 1, are the coefficients of these terms right here. Okay, and the way it works is you have a bunch of you're going to have something else besides the a and the b here. And how do we calculate that out? Well, the way it works is that you have your first expression with the 1 in front of it, is always that number raised to that power, so it's a to the third. And then the next one is with 3. Notice how a went down by 1 power. It's 3a squared b. So a is to the second power now, and then the b start to appear. So b to the first. Next, the a goes down again, so it's a to the first, and the b appears again, but now it's raised to the second. And last but not least, we have all the a's gone and just b to the third. Okay, so try to remember that idea here, and we don't really need these numbers anymore. Just go ahead and erase them. So again, you start with a raised to the power that you're working with, then the next term a goes down by 1, and then b starts to appear, and etc. until you reach the last term, which is just the b raised to the power. Okay, and you have those numbers in the middle. So how does that work for us here with that 5x minus 5x plus 2y, excuse me, to the third? Here our a is 5x, so I'd have 1 times 5x to the third power plus 3 times a squared, which is the next term, so it'd be 5x squared times 2y plus 3 times 5x to the first times 2y squared, and then finally plus, ran out of room here, 2y to the third. And if you went ahead and calculate this out, 5x to the third is 125x to the third. 5x squared is 25x squared, times 3 is 75, times 2 is 150, x squared y. So yeah, that term became that one became that. 3 times 5x times 2y squared, that would be, let's see, 3 times 5 is 15, times 4, that would be 60. And then you have an x, y squared, plus, and then 2 to the third is 8, y to the third. Okay. All right. So we'd have that right there, and that would be it. That's our expansion. You know, this is obviously useful because if you didn't have this, you would have to expand 5x plus 2y to the third by multiplying it out. Like this, 5x plus 2y, 5x plus 2y, 5x plus 2y. And yeah, you'd have to basically multiply this out. It's a little too much in my opinion. So I'd rather use a shortcut, and which is what we just did. So that is that binomial expansion using Pascal's triangle. Now, the second method we're going to go over in the next video is going to be by the binomial theorem. And that theorem is a little more based on a formula, I would say. So stay tuned for that. All right, thank you for your time. Hope this helps.